All right, for our lesson 4.3 focus lesson, guys, our I can statement has to do with generating a set of expressions that follow a pattern. So in number one, we're supposed to find the total number of stars without counting by one. So we need to look for patterns and kind of write an expression to show what I'm seeing, okay, to find this total. So the first thing I recognize here, I see groups of 4. So I think one thing there I could just take, there's 1, 2, 3, 4, 5. 5 groups of 4. So I could have 5 times 4 for an expression. So I know there are 20 stars if I see that pattern there. Another thing I see, if I want to look at it a little bit differently, if I'm looking at rows and columns, what if I look at, here I've got 1, 2, so there's 1, 2, 3, 4, 5, 6. So I could say I've got 6 plus 6 plus 4 plus 4. And I can see those. I could also make this into multiplying because I have 2 columns of 6 here. So I could say 2 times 6. I could put that in parentheses if I wanted. I wouldn't have to. Plus 2 rows of 4. Or 2 of groups of 4. So we have those 2 groups of 4 plus the 2 groups of 6. And if I add that together, again, this becomes 12 plus 8 is 20. Add all these up, you get 20. So there's different ways, different patterns you can have that kind of represent what's going on here based on what you're seeing and how you look at it. So those are just some examples for that pattern. We're going to spend more time on number 2 here, so I'm going to erase and move this a little bit. So we'll pause this if we need to so you can write things down. All right, on number 2, Betsy's favorite place in the park is a large tiled area as shown to the right. And without counting by one, we need to find the number of shaded border tiles. And how many border tiles, move this a little so we can see it all here. How many border tiles are, and we can't count by one. Border tiles are these shaded blue tiles on the outside around the border of this square. So we need to come up with a way and find a pattern to do this. So I see there's 10. So there's 10 squares that go across the top here. So that means it'll be 10, 10, and 10. But again, they're sharing. I see that they're sharing these corners. Okay, so when I see that pattern, could I say I have 4 rows, 4 groups of 10 to give me 40, but then I need to subtract 4 because I double counted the corners. So here could be an expression of 4 times 10, which is 40. Take away 4, that would leave me with 36 of those border tiles. That's one way to look at it if you double count those corners and then take them away. Could I have groups of maybe 9? I could look at it this way and not double count the corners. So I have 4 groups of 9. So I could simply take 4 times 9 if I look at it that way and see that I can see all 4 of those groups. That again gives me 36 of those border tiles. That's another way to look at it there. Could I take 4 times 10 and say those are these 2? Then I'm not going to double count the corners. So can you see that there's 8 in here on each side? So to get that, could I look at that as plus? Could I take, instead of just taking 8 times the 2, could I have 10 minus 2? Because I know there's 10 here. And take away these 2 end pieces. And then I could also take that times 2 because that gets me 8. And then now I double it. So I'm actually going to put the 2 up in front here. Could I look at it this way? 2 times the quantity 10 minus 2. Okay, in this case, we've got 10 minus 2 gives me the 8. And then I need to do that twice, so I take it times 2. And remember, no symbol means multiply. And 10 minus 2 is 8. Do parentheses first. So if I was going to solve this using my order of operations, this would be 40 plus, or excuse me, got this wrong here. It shouldn't be 2 times 4 times 10. It should be 2 times 10. Excuse me. So I've got 2 times 10 plus 2 times the quantity 10 minus 2, which is just 8 twice, which is 16. And this would be 20 then. So 20 plus 16 does equal 36. So sorry about that, but you can see the 2 rows of 10 here. And then instead of just writing 8, notice how I took the 10 minus the 2, these two ends, to get me that 8. All right, so I'm just seeing the pattern of what I have to take away from this whole row of 10. I could have just put in 2 times 8 there as well, but trying to look at this and see this in different ways. Okay. Again, down here and see it says record equivalent expressions that your classmates shared for part B. We're just kind of doing all those at once of different ways that we could think about these. Okay. Let's look at possibly one more. Could I think of these as squares? So this is 10 by 10. If I take this whole thing, I could say it's 10 times 10, or could I say 10 squared? 10 times 10 would give me 100 in here. And take away, I need to take away the white part because I'm just looking for the border tiles. So you can see the white part is 1, 2, 3, 4, 5, 6, 7, 8 by 8. So that's 8 squared, or 64. So if I end up doing the work on that, that just becomes 100 minus 64, which is also 36. Different way to look at it there. Think of it as squares. Find every single square in this thing and subtract out the white part, and that tells me what's left for the border tiles. And every one of these formulas comes up with 36. And guys, we want to eventually generalize this pattern. So I'm going to show a little bit here of a way we could do that. So we could do this for any size square, not just one that's 10 by 10. To figure out the border tile. So I'm going to go a little bit deeper here, and instead of saying there's 10 across here, which I know there is, let's just say, let's call this n. Okay, and I could say, and I'm going to use this formula here, kind of a basic one there, but instead of saying 10, let's say 4 times n, and n stands for the number in this row, okay, the number of squares in there, which in this case is 10, but it could be anything. If I had 9 or 8, it would stand for that. So n is my variable that represents the number in this row here. And if I take 4 times n and subtract 4, I would subtract those border tiles, and I'd get on the corners, and I would get my total no matter what I plugged in here. So if there's only 9 in a row, I could plug a 9 in here, etc., and it would do 4 rows of 9 and subtract the 4 and get me 32. So for any size, I could figure this out. And an easier way to write this, remember we don't need a times sign or a multiply sign. You could say 4 times n minus 4. And in this case, that formula would be able to find the number of border tiles in any size square that I had up here. And I could also do that and put in these in place of 10 and get this to work as well using those other formulas. But what you'll find is this formula, any formula that I use, can get me back to this base formula here, and they can all turn into the same if I combine like terms, which is something we'll be working on in the future. But really starting to look at this as algebra, and can I find a pattern and come up with a formula for it. And this is just one example of where we're going to work on doing this. And you guys will do a few practice problems here, trying to think like this and come up with patterns and equations and expressions that'll help us be able to solve a problem like this with a pattern.